Welcome to qnawire.
So in this problem, we are given this graph, and we're told this graph is either going to be our function f of x, the first derivative of our function f of x, or the second derivative of our function f of x. And we want to find the inflection points given this graph is one of those functions. So in part A, we're going to be assuming that this is the graph of our function f of x, and we want to find the inflection points. So the inflection points of our function f of x are going to be at the points where we change in concavity, so when we go from concave up to concave down, or from concave down to concave up. And it might be a little bit harder to figure that out with my sketch, but it was a little bit more clear in the actual graph of this, that the inflection point would be at this point here when x is equal to 3, and at this point here when x is equal to 4, or sorry, when x is equal to 5, and then those are the only two inflection points. So the reason that I know this is because we have a concave down graph that then changes to concave up here, and now we're concave up, and then we change again to concave down at this point here. So since we're changing in concavity, that means that these are inflection points. So let's say the inflection points, or IPs, are at x is equal to 3 and x is equal to 5. And for part B, we're going to figure out where the inflection points are, given that this is the derivative of our function f of x. So if we look at this graph again, the inflection points, or how to find an inflection point given that this is the derivative of our function f of x, is going to be wherever our function has a maximum or minimum value. That's going to be where we have inflection points for our function f of x. And the reason for that is because we're going to be having zeros for the derivative of our derivative of f of x, or for our second derivative at these maximum and minimum values. And we're also going to be going from positive to negative, or negative to positive, in terms of our second derivative at these maximum and minimum values. We're not going to be going from positive to then hitting 0 to then positive again for our second derivative, since these are maximum and minimum values. So the maximum and minimum values of our function occur at x is equal to 2, at x is equal to 4, and at x is equal to 6. So our inflection points are at x is equal to 2, x is equal to 4, and x is equal to 6. And for part C, we're going to assume that this is the second derivative of our function f of x. And to find the inflection points, given that this is the second derivative of our function f of x, those are going to be at the zeros of our function f double prime of x, but they also have to go from negative to positive, or positive to negative. We have to have a sign change after this 0 for it to be an inflection point. So that only occurs here at x is equal to 1 and at x is equal to 7. Since at x is equal to 4, at this point, it is a 0, but we go from positive values to then positive values again, so we're not actually changing concavity. We're not going from concave up to concave down. So the two inflection points, given that this is the second derivative of our function, are going to be at x is equal to 1 and at x is equal to 7.